Now what we have here is what we call a modified Atwood machine. And this is a really important piece of equipment because this is going to help us find one of the most important relationships between force and acceleration that we have in physics. So kind of the basic setup of a modified Atwood machine is we have kind of our main object. We have a cart right here, and it's attached to a string attached to a hanging mass, so that when we let this thing go, the hanging mass helps with that force of tension and kind of pulls our cart along the track. That's kind of the basic setup of how your modified Atwood machine works. So we're going to use this setup to try and answer the question, what relationship, if any, exists between the mass of the cart versus the acceleration of the cart? So a lot of our work is focused on the cart itself. So let's kind of dive into the little aspects of each piece of our Atwood machine. So we know how to run it. We just kind of let this thing go, and our hanging mass will allow that object to accelerate down the track. But let's focus in on the mass for right now. So what I've done is I've already measured out the mass of our cart and the mass of our force sensor. So these two combined is going to give us a mass of 0.32 kilograms. So that's without any mass on it at all whatsoever. And we have a few options available to us. You're going to have 2.1 kilogram masses, you're going to have 1.2 kilogram mass, and you're going to have 1.5 kilogram mass. So we can just put whatever mass on the cart that we want. So we'll kind of add that mass plus the 0.32 of our cart and our force sensor together. So that's kind of how we can manipulate the mass of the cart. Let's talk about the force. Now, the thing that is actually providing that force, according to the cart, is tension, because we have a very, very thin string right here. And it's attached to our force sensor. So if we hook this up to our computer, do some graphical analysis, we can figure out how much force of tension is acting on our string right here. But we know in reality the thing that is providing that force or allowing that tension force to happen, if we follow it down, is our hanging mass right here. So if we need to manipulate that, I already have a 10 gram mass right here. So we can convert that into kilograms as needed if we need to. And we also have 9 10 gram masses here if we need to play around with that. But really what we're doing is we are trying to figure out what the mass over here, and that will change the force on our force sensor. So when we run it, we'll hook it up to our computer, we'll collect that data, and we can see how much force is acting on our cart. So let's look at what graphical analysis will give us for force readings. So I let my cart go. I collected my force data as it went down the track. And so here we have our little bit of force information for the time that it was running down the track. I've got this nice horizontal line. Now, what's really important is you need to specify exactly what part of that graph are you analyzing so that the data represents the motion that you are selecting. So what I'm going to do is I'm just going to go through how to find that force. So I'm going to select just the entire thing as an example. So I'm going to click and drag that whole thing. And I need to figure out what is kind of that average value of the motion there, of the force. So I'm going to click on this button down here, and I'm going to go to View Statistics, and right away that tells me that my average or my mean is 0.535 newtons. So going down the track gives me an average tension force of 0.535 newtons. But again, it's going to be incredibly important that you select only the part of the graph where your cart was moving the way you wanted it to. So we've talked about figuring out the mass of our cart. We've talked about how to find that tension force through graphical analysis. The last bit of information we need is how to get acceleration. So to help us out, we have our motion detector here that's going to collect data as our cart is moving down the track. So just like we've done before, if we collect that data and look at the graph, we're going to be able to do a little bit of analysis to figure out the acceleration. So let's look at an example of what that might look like. So here's the graph that I collected when I ran my cart and collected data through the motion detector. So we have this nice position graph where we have a little curve going on. We have a velocity graph with a little bitty incline. The thing that I really want to get, though, is acceleration. That's the thing that's important to me. And there's a couple of ways that we can find our acceleration. Now, in class, we've talked about how to find acceleration from a velocity versus time graph, we need to figure out the slope of that line. So let me show you how to do that. Again, you're going to have to be very, very careful about what part of your graph you are deciding to use. Make sure you're only selecting the part of your graph that represents the motion that you want. Just to show you everything, I'm going to select all of this stuff. And I'm going to go to my graph icon. I'm going to apply a curve fit and say it's linear because we should have a little angled line. And it gives me my y equals mx plus b. So for a velocity graph, the slope is my acceleration. So as I look here, my m is my slope, so it looks like I have an acceleration of 0.04068. Not too bad. That's one way to do it. Here's a second way we could do that. I'm going to get rid of that guy. I'm going to change this to 3 graphs so I can actually pull up my acceleration. So I have position, velocity, acceleration. Hey, if we want to get that directly from acceleration, we can definitely do that. Just like we did for the force, select the portion of the motion that you want, that you need, and go to View Statistics and figure out what that median is. So if I scroll down a little tiny bit, my average, according to what I selected, is 0.011 meters per second squared. So there's a couple ways of doing it. Make sure you are talking about which way you are selecting to use, and make sure you are telling me exactly what portions of the graph you are using to get that data.